The weight of the cylindrical tank is negligible in comparison to the height of water it contains. Water weighs 9.81 kN per cubic meter. The coefficient of static friction between the tank and the horizontal surface is mu. Given the height of the tank equals 3.2 meters, diameter of the tank is 1.5 meters, and the angle alpha here is equal to 60 degrees. Number 1. Assuming a full tank, find the smallest force P required to tip the tank. Number 2. Find the smallest coefficient of static friction mu that would allow tipping to take place. Number 3. If the force P equals 6.5 kN initiates tipping, determine the depth of water in the tank. Okay, so here's the tank again with the different forces acting on it. Now, since the problem says it is on the verge of tipping, it means the tank is going to be touching the surface at point A only. So that means our normal reaction will be here. So we have N sub A. And then we have the frictional force at A. And then the force P here, which is 60 degrees from the horizontal, is being resolved to its vertical and horizontal components. And then at the middle, we have the weight of the water. Number 1 states that the tank is full of water. So that means the weight of water will be equal to the volume of the cylinder times the density of water, which is 9.81 kilonewtons per cubic meter. So this will be equal to 9.81 times the area of the base. That will be pi times the diameter of the tank square divided by 4. That's the area of the base. We'll multiply that by the height, which is h tank. But the following dimensions are given. The diameter of the tank is 1.5 meters. The height of the tank is 3.2 meters. Okay, so let's just put 1.5 here. And this is 3.2. So weight of water is 55.474 kilonewtons. We're also given alpha equal to 60 degrees. But in this software, when we are going to use trigonometric functions, the angle alpha should be in radians. So let's multiply this by pi over 1/8. So that's the angle 60 degrees equal to 1.047 radian. And let's solve sine of alpha. That's 0.866. So we'll just write 0.866 while cosine of alpha is 0.5. So this will be 0.5 p. Okay, now we are ready to solve for P. We'll just do summation of moment at A equals 0. So we're summing up forces here. That means this weight of water is going to create a clockwise moment. We'll consider that positive. While these two components here is going to create a counterclockwise moment. So we'll start with this one. W sub water times the moment arm will be half of this diameter of the tank or the radius divided by 2. Minus these components here. The horizontal component is 0.5 P. The moment arm of this force is this one, the height of the tank. Minus the vertical component, this one, times the moment arm, which is the diameter of the tank, equals 0. Let's move this one a little bit down here. Okay, so the only unknown here is P. Weight of water is 55.474. Diameter of tank is 1.5. Height of tank is 3.2. And this is also 1.5. So let's evaluate this one. How much is this? Equals 41.606. That's 41.606. Then here we can group these two terms with the unknown P. And let's factor out P. Then this sign becomes positive. And let's factor out P. That's P times. We'll remove the P inside the parentheses. And let's evaluate this. How much is this? 2.094. So this becomes 2.904 times P. Then we'll delete this one. Next, we are going to subtract 41.606 to both sides of the equation so that this first two terms will cancel out or will be equal to 0. Then we'll divide the whole equation by negative 2.904. So the coefficient of P will cancel out and we'll get our P. 14.327 kilonewtons. Okay, let's see. That's letter B. Number 2, find the smallest coefficient of static friction, mu, that would allow tipping to take place. Okay, we'll do summation of forces vertical first. We'll be able to solve for N sub A because the vertical forces includes N sub A, the weight of water, and the vertical component of P. So our equation will be N sub A plus, this one is positive because it's going up. This one is minus, equals 0. I think we have solved P already. P is 14.327. Let's substitute that here. And the weight of water is 55.474. So how much is this? Equals negative 43.067. So our N sub A is 43.067 kilonewtons. And then we'll do summation of forces horizontal equals 0. So horizontal forces are F and horizontal component of P. But F is mu times NA. So our equation is mu times NA minus this horizontal component here equals 0. So we'll add 0.5 P to both sides of the equation so that these two terms here will be 0. Okay, so we'll divide both sides of the equation by N sub A. So this coefficient here will cancel out. And our mu is equal to 0.5 of P divided by N sub A. Our P is 14.327 and our N sub A is 43.067. Our mu therefore is equal to 0.166. That's letter D, 0.17. If the force P 6.5 kN initiates tipping, determine the depth of the water in the tank. Now, the height of water is different from the total height of the tank. So our weight of water will now be different. Weight of water will be equal to the density in kilonewtons per cubic meter times the area of the base, pi times d square, our diameter is 1.5, over 4, that's the area of the base, times the height of water. So how much is this? That's equal to 17.336. Okay, so weight of water is 17.336 times height of water. Okay, to solve the height of water, we can sum up moment at A. Yeah, we can do that because we are given P. P, by the way, is 6.5 kilonewtons. Okay, let's go back here and use summation of moment at A. This one. Okay, so summation of moment at A. It's the same equation. However, the weight of water becomes this one, 17.336 times height of water. Diameter of tank is still 1.5. P is now given at 6.5 kilonewtons. Height of tank still the same at 3.2 meters. Again, this is 6.5 and this is 1.5. Let us evaluate these constant terms first. This is, by the way, negative equals negative 18.779. And this one, how much is this? Equals 13.002. Okay, so we can add 18.779 to both sides of the equation. Then the last two terms will be 0. Next, we will divide the whole equation by 13.002. So this coefficient here will cancel out, or that's equal to 1. So our depth of water is equal to 1.444 meters, or this one, 1.45. So our answers are for number 1, B, 14.35 kilonewtons. For number 2 is D, 0.17. And for number 3 is A, 1.45 meters.